Greetings and salutations, young true believers. So, after thinking about it for a while, I decided we're going to forego the rest of Chapter 9 because Chapter 9 concerns natural deduction, that is to say, formal logic, and that's a really difficult procedure, etc., set of concepts to wrap your mind around unless you're in a classroom and you get a chance to, actively work on that stuff on a, regular basis. Um, it's definitely not something, in my estimation, that you can learn asynchronously. So, in lieu of doing formal logic deductions, and because this is a critical thinking course, and because it's election season, and conspiracy theories are rife, I thought it would behoove us to talk about what constitutes a good theory and try to debunk some conspiracy theories, which, as you will see, turns out to not be all that difficult. So, why do you formulate a theory at all? Why is theory necessary, right? Well, consider, gang, if you observe a phenomenon and you don't have a theory to help you organize your observations, then all you have is a set of observations with nothing to bind the observations together. That's what theories do. They bind together. They make your observations consistent with one another. That's why theory is absolutely indispensable to philosophy. It's indispensable to history, to music theory, art theory, right? You have to have something to, again, to make your observations harmonize with one another, right? So, very often we propose a theory as an explanation for a phenomenon, or we may have a theory thrust upon us for consideration. So the question then becomes, well, what makes for a good theory, right? All right, so let's take a simple example. You walk out to your car in the morning and it doesn't start. So you run down the 5 most likely culprits: dead battery, 2, out of gas, 3, the alternator's bad, 4, the starter's bad, or 5, some combination of those, right? Okay. Now, it's equally interesting to note what you did not posit as a cause for your car not starting. For example, nobody said you're sleepwalking and you sabotage your car at night while you're sleepwalking, right? Um, Nobody said that extraterrestrials zapped your car with an electromagnetic beam and that's why it won't start. Nobody says that a ghost is haunting your engine, right? Nobody posits that a wizard put a curse on it, right? Etc. We could go on, right? Nobody says you drove through a alternate space-time dimension and messed up the electrical system. So those last 5, right? Why not posit those, right? I mean, after all, quantum mechanics is a really weird theory, and it turns out to be pretty, yeah, as far as we can tell, it's very accurate and most likely true, right? So what's wrong with those last 5, right? Well, if you think they're not good, why not? A theory's strangeness, again, as is in the case with quantum mechanics, does not automatically disqualify it because, again, quantum mechanics is really weird, right? So, a simplified answer to the problem of theory choice is this: just weigh the evidence for each theory, and the theory with the most evidence wins. As we will soon see, the amount or degree of evidence that a theory has is indeed a crucial factor, but it can't be the sole criterion by which we assess explanations. So, what do we do? Well, one thing I want you guys to remember, and I think we talked a little bit about this earlier in the semester, remember Occam's razor, the principle of parsimony. So William of Occam was a medieval philosopher, and he famously argued that you should never posit entities beyond necessity. So what's that mean? Well, let's boil it down. When you're trying to explain a phenomenon, when you're offering an explanation or a theory, right? The simplest theory that explains the phenomenon is usually the correct theory, right? In this, go back to our example, the car won't start. The simplest theory is that it's one of the 5 causes we listed, right? Dead battery, out of gas, bad alternator, bad starter, bad fuel pump, Those are the most likely explanations, right? We don't need to go into, supernatural or high weirdness, as they call it these days, explanations, right? So, what I want to introduce now is what's known as the criteria of adequacy, right? A theory judged by these criteria to be the best explanation for certain facts is worthy of our belief, and we may legitimately claim to know that such a theory is true, all right? So, what are these 5 criteria? Well, the first one is testability, right? Most of the theories that we encounter every day and all the theories that scientists take seriously are testable. There is some way to determine whether the theories are true or false. We can subject them to a test. If one of you made the bold hypothesis, just for example, that water boils when heated to 100 degrees C or 212 F, we can test it. Likewise, if somebody posited that water will freeze if it is cooled to 32 F or 0 C, we can test that, all right? A theory is testable if it predicts something other than what it was introduced to explain. So suppose your clock stops each time you touch it. One theory to explain this event is that there's an electrical short in the clock's wiring. Another theory is that an invisible demon causes the clock to stop. We can test the wiring theory. We cannot test the evil demon theory, right? So all things being equal, testable theories are superior to untestable theories. 2, fruitfulness. So imagine we have 2 testable theories, theory 1, theory 2, that attempt to explain the same phenomena. Theory 1 and theory 2 seem comparable in most respects when measured against the criteria of adequacy. Theory 1, however, successfully predicts the existence of a previously unknown entity, say a star in an uncharted part of the sky. What would you conclude about the relative worth of these 2 theories? So if you thought carefully about the issue, you might conclude that theory 1 is the better theory, and you would be right. All things being equal, theories that perform this way, that successfully predict previously unknown phenomena, are more credible than those that don't. They are said to be fruitful, right? Meaning they yield new insights that can open up new areas of research and discovery. This fruitfulness suggests that these theories are more likely to be true. So, I'll give you a historical example of this. Decades ago, Albert Einstein's theory of relativity gained a great deal of credibility by successfully predicting a phenomenon that was extraordinary and entirely novel. The theory predicts that light traveling close to massive objects such as stars will appear to be bent because the space around such objects is curved. It's warped, in other words, right? The curve in space causes a curve in nearby light rays. At the time, however, the prevailing opinion was that light always travels in straight lines, no bends, no curves, no breaks. In 1919, the physicist Sir Arthur Eddington devised a way to test this prediction. He managed to take 2 sets of photographs of exactly the same portion of the sky when the sun was overhead in daylight and when it was not at night. He was able to get a good photo of the sky during daylight because there was a total eclipse of the sun at the time. If light rays really were bent when they passed near massive objects, then stars whose light passes near the sun should appear to be shifted slightly from their true position, as seen at night. Eddington discovered that stars near the sun did appear to have moved, and that the amount of their apparent movement was just what the theory predicted. This novel prediction then demonstrated the fruitfulness of Einstein's theory, provided a degree of confirmation for the theory, and opened up new areas of research. So, on Wednesday, we will talk about the 3 other factors in the criteria of adequacy. They are scope, simplicity, and conservatism, right? And that the political doctrine of conservatism, right? But we'll probably spend 2 weeks on what makes a good theory and debunking conspiracy theories. And I'm leaning toward having you guys write on debunking a conspiracy theory for your final essay. But stay tuned for that. I'll have more detail for you on that in the weeks to come.